What's up guys, in this video I will show how to determine the system of equations using either reduced row echelon form or Gauss-Jordan elimination. So as you can see here, here's the numbers that we have, and the first step we do have to do is to augment it. So we have to do the following thing, which is here's x1 and this is x2, and the equal sign we will do it in matrix as a dotted lines, and here is whatever numbers that we have, so set it to n. So in x1 we do have 2 and 3, and we do have 14. In the second row we do have 4, 5 and 20. Now try to convert this number into 1 and this one into 1, and wherever below and above ones must be zeros to finish solving the problem. So to change this number and make it 1, we do have to multiply it by 1/2. So 1/2 times the whole row, which is 2, 3 and 14, will give us R1, which is row 1. So just follow what I'm doing and do that. 1/2 times 2, it will be 1. So we did what's supposed to do. Now we do have to multiply 1/2 by 3, which it will be 3 over 2, and 1 over 14, so 14 times 1 divided by 2, it will be 7. Now let's try to just like these numbers as they are, and we will try to solve the 4 and make it 1. So now we did finish with the first row by making it 1. Now let's try to make this one as 0, because anything below and above 0 must be below and above 1 must be 0. So let's say -4 times R1 plus R2, it will give us a 0 for the place of 4. So you can take the first row as is, because we are not going to multiply anything now. So -4 times 1, it is -4 plus 4, which is 0. -4 times 3 halves, so -4 times 3, which is -12, divided by 2 is -6, plus 5, which is -1. Now -4 times 7, which is 7, 14, -28, plus 20, and which it will be -8. Okay. Now the next step, we do have to make this -1 converted into 1. So just multiply -1 times R2, and it will give us R2. So 1/3, 7. I'm just plugging these numbers as they are, because we are not multiplying anything for R1, but we are multiplying it for R2. So -1 times 0, it's 0. -1 times -1, it will be 1. And -1 times -8, it will be 8. Now let's try to make the 3 halves equal to 0. And I guess you think you know what the number it will be. So negative 3 halves times R2 plus R1, it will give us R1. So negative 3 halves times 0, it will be 0 plus 1, which is just 1. Negative 3 halves times 1, which is negative 3 halves, plus 3 halves will give us 0. And negative 3 halves times 8, it will be negative 3 times 8, which is negative 24. Divide by 2. So it's, so let's say negative 3 times 8 plus 7, which is negative 24 over 2 plus 7. And negative 12 plus 7, which is negative 5. So instead of 7, we will add negative 5 here, and just take whatever you have in R2 and write it down again as it is. And as you can see, we have for x1 is negative 5, and for x2 is 8. And because it's 0 and 1, I do believe because we do have all leading ones, it will be consistent. Because we do have the 1 0 0 1, so it will be a consistent. And to interpret this the solution is that x1 x2 such that is x1 is negative 5 and x2 is 8. And that's all the solutions for this problem. Thanks for watching.